Hi students, today we are going to continue with your topic dual nature of radiation and matter, and this is your third lecture. My name is Ratnaprabha Patil. In last two lectures we have discussed about some introduction, then the photoelectric effect, then experimental setup of photoelectric effect, observations from experiments on photoelectric effect. Now we are going to discuss about failure of wave theory to explain observation from experiments on photoelectric effect. This means what? If we are considering the light or electromagnetic radiation as a wave, then we cannot explain the photoelectric effect, right? So we are going to discuss about that. Means with consideration of wave theory, we by considering light as a, or electromagnetic radiation as a wave, we cannot explain photoelectric effect, and why this thing we are going to discuss in these points, right? So first is the instantaneous emission of electrons on incidence of light. As we have discussed before, that when light or electromagnetic radiation of particular frequency is incident on metal surface, then that metal emit electrons, but at that time only. Means there is a no time lag between the emission of electrons and light fall on the metal. Okay, so the metal surface will require reasonable time to accumulate sufficient energy to knock off electrons. Okay, this is the consideration that when light is incident on metal surface, it will take some time to knock off the electron from the metal surface. Means it will absorb some energy, and after some time it will lose or it will emit electron. But this is not happening when light is incident on metal surface. Immediately at that time only electrons are getting or knock off from the metal surface. This is the observation and this is the thinking. Second point is what? Thinking. This will happen, लेकिन ऐसा हुआ नहीं. हो क्या रहा है? जब लाइट इंसिडेंट हो रही है, at that time electrons are coming out from the metal surface. Okay, greater the intensity of incident radiation, more will be the incident energy. Hence expected time required to knock off the electron will be less. This means what? If intensity of incident light is more, energy of means energy is more. When intensity of incident radiation is more, then there will be the more incident energy, and hence the time lag which will be there for emission of or ejection of electrons will be less. For small incident intensity, the energy incident on area in unit time will be small and will take longer to knock off the electrons. If intensity of incident light is less, energy is less, and due to that it will take, or metal will take, longer time to knock off the electrons. These arguments are contradictory to observations. मतलब ये तीनों ऑब्जर्वेशन जो है सेकेंड, थर्ड एंड फोर्थ, ये आर्ग्यूमेंट जो है वो ऑब्जर्वेशन से डिफरेंट है. ऑब्जर्वेशन क्या है? इंस्टेंटेनियस इमिशन ऑफ इलेक्ट्रॉन्स ऑन इंसिडेंस ऑफ लाइट. बट साइंटिस्ट क्या सोच रहे थे? मेटल विल टेक सम टाइम आफ्टर light fall on the metal, means it will accumulate, or it will accumulate sufficient energy. After some time metal will emit electron. If intensity is more, energy of incident radiation is more, and it will take, or electrons will take, less time to knock off from the metal. If intensity is less, then electron will take longer time to knock off from the metal surface. Okay, these three arguments are contradictory with the observation. Observation कौन सा है? First. Okay, metal have free electrons, hence it is the good conductor of heat and electricity. This you are knowing. Electrons cannot escape from the metal surface unless sufficient energy is supplied to them. Okay, if you are providing less energy to the metal surface, there will not be any ejection of electrons from the metal surface. The minimum amount of energy required to be provided to an electron to pull it out from the metal surface is called as work function. As we have discussed before, photoelectric effect में क्या है? We should incident a radiation which will have some particular frequency, that is called as threshold frequency. If frequency is less than threshold frequency, there will not be any emission of electrons from the metal surface. Okay, and that is, हमने वहाँ पे फ्रीक्वेंसी के टर्म में बात की थी, अब हम क्या कर रहे हैं? एनर्जी के टर्म में बात कर रहे हैं. दैट इज मिनिमम अमाउंट ऑफ एनर्जी रिक्वायर्ड टू बी प्रोवाइडेड टू एन इलेक्ट्रॉन टू पुल इट आउट ऑफ द मेटल surface. Okay, and that minimum amount of energy is called as work function, and its symbol is phi 0. Work function depends on the properties of metal and nature of its surface. Okay, then larger the intensity implies larger energy. The electrons are expected to be emitted with larger kinetic energy. Again, this will not be the correct assumption that if intensity, आपने पहले भी पढ़ा है in the observations that intensity doesn't play any role in the ejection of electron. If intensity is less and frequency is sufficient, yet metal ejects electrons will eject from the metal surface. So this argument is wrong, but the observation showed that the maximum kinetic energy depends on frequency, not on intensity. Okay, means frequency is the factor on which metal emit electron. If frequency is sufficient, that is, frequency should be more than threshold frequency. If frequency is less than threshold frequency, there will not be any emission of electrons from metal surface. And emission of electron doesn't depend on intensity. According to wave theory, frequency of incident radiation has no role in determining the kinetic energy of electron. Again, this is one argument. What? According to wave theory, frequency of incident radiation has no role in determining the kinetic energy of photoelectron. But observation क्या है? If that is frequency is the frequency of incident radiation has role in determining the kinetic energy of photoelectrons. Wave theory expected photoelectrons to be emitted for any frequency if intensity of radiation was large enough. But observation क्या है? Observation is different than wave theory expected. That is, photoelectrons to be emitted for any intensity if frequency of radiation was large enough. Okay, but observation indicates that for given metal surface, cutoff frequency nu0 existed below which no photoelectrons were emitted, however intense the radiation was. That is what I am saying. nu0 क्या है? Threshold frequency. Above this frequency, there will be the emission of photoelectrons, that is electrons from metal surface, whatever the intensity of incident radiation is. If frequency of incident radiation is less than this nu0, then there will not be any emission of electrons from metal surface, whatever the intensity is. If intensity is more, frequency is less than this nu0, there will not be any emission of electrons from metal surface. Photoelectrons were always emitted if the incident frequency nu is greater than nu0, even if the intensity was low. Okay, this is all about failure of wave theory to explain the observations from experiments on photoelectric effect. Means by considering electromagnetic radiation as wave, we cannot explain the photoelectric effect. That is, observations in the experiment of photoelectric effect is different than the wave theory expected. Okay, then next point is Einstein's postulate of quantization of energy and the photoelectric equation. What Einstein proposed? Einstein proposed that under certain conditions, light behaves as if it was particle. Means sometime light behave as a wave and sometime it behaves it was particle. When it behaves like a wave, when you are studying the experiments or phenomenon like interference, diffraction, polarization, reflection, diffraction, In these phenomenon, light will act or behave like a wave. But if we are considering the photoelectric effect or black body radiation, then light behave as if it was particle. Okay, its energy is released or absorbed in bundles or quanta. Light energy, it is released or absorbed in the form of bundles, not continuously. Okay, Einstein named the quantum of energy of light as photon with energy E is equal to h nu, which we are using always. Energy of photon is equal to E is equal to h nu. Okay, light is released in the form of bundles or quanta. Okay, and that quanta, Einstein gave the name for that quanta is photon, and energy of photon is given by equation h nu, where nu is the frequency of light and h is Planck's constant, which is having value 6.626 into 10 raised to minus 34 joule second. Now the equation E is equal to h nu is the relation between particle like property, the energy, and wave like property, the frequency. Means energy किसके पास होगी? पार्टिकल के पास, and फ्रीक्वेंसी ये फिजिकल जो क्वांटिटी है हम किसके लिए यूज करते हैं? वेव के लिए. मीन्स E is equal to h nu is what? E is energy is related to particle, nu is related to frequency. Means Einstein यहाँ पे क्या बोलने की कोशिश कर रहे हैं? That sometimes light will act as a wave and sometimes will act as a particle. Einstein's relation says that energy of electromagnetic radiation is directly proportional to frequency. As you can see in the equation, E is equal to h nu. H क्या होता है? Planck's constant is constant. So instead of equal to sign we can write proportion. So E क्या हो जाएगा? E is directly proportional to nu, that is energy of photon is directly proportional to frequency and inversely proportional to wavelength. You are knowing that frequency and wavelength are reciprocal with each other. High frequency radiation means high energy radiation. As energy is directly proportional to frequency, frequency is more, energy is more. Alternatively, short wavelength radiation means high energy radiation. Okay. So we are going to start with the first postulate of Einstein, that is when a photon of ultraviolet radiation arrives at the metal surface and collide with an electron, it gives all of its energy h nu to the electron. If means someone is doing photoelectric effect experiment in which that person is going to incident a light, that is ultraviolet radiation on the metal surface, then what will happen? That photon collide with the electron and give its energy h nu to the electron. The energy gained by electron and the photon no longer exist. means when ultraviolet radiation or photon is incident, or photon of ultraviolet radiation is incident on metal surface, then means we are providing energy in the form of ultraviolet radiation of some particular frequency, right? So, and all the energy gained by electron and the photon, means that photon is absorbed by electrons on the metal surface. If phi 0 is the work function of material of the emitter plate, then electron will be emitted only if the energy gained by the electron is more than or equal to work function. As we have discussed before, that work function here, work function is what? Minimum amount of energy required to be provided to an electron to pull it out of the metal surface. Okay. If work function means if energy is less, that is if we are providing minimum energy, then there will not be any emission of electron from the metal surface. If energy is less, work function is less, that is work function is what? Minimum amount of energy provided to the electrons in the metal surface to eject from that metal surface. Okay. So H nu is what? Energy. If energy is greater than or equal to work function, then and then only metal will emit electrons. A minimum or threshold frequency, that is nu 0 is what? Threshold frequency is required to eject electrons from the metal surface. This we have discussed earlier also. If nu is less than nu 0, the photon will not have enough energy to knock off or liberate an electron. Means if incident frequency of radiation is less than threshold frequency, there will not be any emission of electrons. No electrons will ejected, however intense the intensity of radiation is. If nu is greater than nu 0, the energy will always be sufficient to eject an electron, however small the intensity of incident radiation is. Okay, this we have discussed earlier also. Now, energy is given by the photon to the electron as soon as the radiation is incident on the surface. Energy exchange between photon and electron is instantaneous, means immediately. This process will happen immediately. When light is incident on metal surface, immediately electron will eject out from the metal surface. Means this energy exchange between photon and electron is very fast, or you can say instantaneous. No time lag between the incidence of light and emission of electron. That is the first point is, when light is incident on metal surface, immediately electron will eject out from the metal surface. There will not be any time delay or time lag. Photo emission is stopped immediately when the incident radiation is stopped. There are no photons to transfer the energy to the electron. Means if source of light is switched on, there will be the switched on, or you can say When light is incident on metal surface, then there will be the emission of electron. When incident light is stopped, emission of electron from the metal surface stopped immediately. Okay. If the intensity of incident radiation for given wavelength is increased, then what will happen? There will be an increase in number of energy quanta, that is photon, incident on unit area in unit time. If we increase the intensity of incident light, what will happen? Number of photon incident on unit area in unit time will what? Increase. Intensity is related to the number of photon. Okay, so large number of photons will incident on unit area in unit time. The energy of each photon is same. Number of photon will increase but energy of each photon is same. Larger intensity radiation will knock off more number of electrons from the metal surface. So, photocurrent will be larger. If large number of photons, if number of photons are incident on metal surface increases, what will happen? More number of electrons will eject out from the metal surface. So, photocurrent will be larger. Lower intensity means less number of ejected electrons and therefore low current. Once the electron is emitted from the metal surface, then what will happen? If collector is at higher potential than the emitter, the electric field will accelerate the electrons towards the collector. As we have seen before also, when emitter is what? Cathode and collector is what? Anode. If there is a higher potential difference between emitter and collector, what will happen? Collector will pull or attract all the electrons which are coming out from the emitter, and due to that electrons will or electric field will accelerate the electron towards the collector. Higher the accelerating potential, more will be the number of electrons reaching to the collector. Means collector का potential पॉजिटिव पोटेंशियल जितना ज़्यादा होगा, then more number of electrons will reach to the collector, and due to this photocurrent increases with accelerating potential initially. The intensity of incident radiation determines the number of photons incident on metal surface. Intensity also determines the maximum number of electrons that can knock off from the metal surface. This we have seen in your third point. For given intensity, increase in accelerating potential can increase current only till all the ejected electrons reach to the collector. Means if we have increased the collector potential, then current or accelerating potential can increase the current only till all the ejected electrons reach to the collector. Increase in current takes place up to certain limit called saturation current. This point again we have discussed before, that is when we increase the potential on collector plate, what will happen? Current will increase till all the ejected electrons reach to the collector. After that what will happen? If number of electrons emitted from the metal surface, the emitter is same, so what will happen? After that, same number of electrons will go towards the collector plate, and due to that there will be the increase in current will stop, and you will get the saturation, and that is called as saturation current. Okay, so we'll discuss next point, that is increasing the incident intensity will increase the number of incident photon and eventually the saturation current. If we increase the incident intensity, what will happen? Number of photon incident on metal surface will increase, and due to that number of electrons emitted from the metal surface also increases, and due to that what will happen? Saturation current also increases. If the frequency of incident radiation is more than threshold frequency, what will happen? The energy phi 0 is used by electron to escape from the metal surface, and remaining energy of the photon became the kinetic energy of electron. Means photon की जो energy है, it is used in two parts. If means part of energy is used to detach electron from the metal surface, and remaining will give the potential energy kinetic energy to the electrons. Maximum kinetic energy of electron is given by Ke max is equal to h nu minus phi 0. H nu is what? Energy of photon, minus phi 0 is what? Work function, means minimum amount of energy required to detach the electron from metal surface. This equation is known as the Einstein's photoelectric equation. Maximum kinetic energy of electrons depends on the material of emitter plate and incident frequency, and it is independent on intensity of the incident radiation. Next will be electrons that are emitted from metal surface have different kinetic energies. It is because all the electrons in solid do not have same energy. Electrons may eject from different depths, means different layers of metal. Electron may suffer collision before coming out from the metal surface. Due to collision there will be the loss of some energy, and due to that all the electrons which are ejected from the metal surface does not have same energy. If V is the potential difference between emitter and collector is at lower potential, electron will lose its kinetic energy in overcoming the retarding force. When we have studied experimental setup of photoelectric effect, what we have studied that we can change potential of collector, that is it can be positive, that is positive potential, or negative potential. If collector is at negative potential, then what will happen? Collector is at lower potential, electron will lose its kinetic energy in overcoming the retarding force. If collector is having less potential or negative potential, what will happen? It will repel the electrons which are ejected from the metal surface. That is, so its kinetic energy is used to overcome the retarding force. Kinetic energy of electron is less than, it may not reach to the collector. Is at lower potential and photocurrent will be 0. Okay. The kinetic energy of electron is less, then it may not reach. Means when light is incident on metal surface, if kinetic energy of electron which are ejecting out from the metal surface is less, maybe it will not reach to the collector, and due to that, or maybe electron will not reach to the collector due to its lower potential. There is a both case, and due to that photocurrent will be 0. If kinetic energy max is the energy of most energetic electron at the emitter surface and minus V0 is the stopping potential, then electron will fail to reach the collector if Ke max is less than EV0. Means what? Minus V0 is what? Potential of collector plate, and this is what? Stopping potential. Means this is the maximum potential, negative potential. Due to that, electron will not reach to the collector plate, and this potential should be what? That is Ke max is less than EV0. If the electron just failed to reach the collector, Ke max is equal to EV0 and photocurrent becomes 0. If the ejected electron have kinetic energy more than EV0, electron can reach to the collector and current flows. Ke, that is kinetic energy of electron, is less than or equal to EV0, then no current will flow. This we have discussed in 7th point. Kinetic energy of electron is less, then it may not reach to the collector, is at lower potential, and photocurrent will be 0. Now, by using Ke max is equal to h nu minus phi 0, that this is Einstein's photoelectric equation. Ke max is what? EV0, which is equal to h nu minus phi 0. Then, or you can write V0 is equal to h divided by E nu minus phi 0 divided by E. All above arguments thus bring out the fact that magnitude of photocurrent depend on the incident intensity through the number of emitted photoelectrons and the potential V of the collector, but not on the incident frequency. Okay. So, observation related to experiment on photoelectric effect explained by Einstein is what? Existence of photon or treating light as a bundle of energy. According to Einstein, energy of radiation of frequency nu comes in bundle with magnitude h nu. Energy of light beam having n number of photons will be n h nu. Okay, this is all about your third lecture. Next part we will discuss in next lecture. Thank you.